All right, so tonight's homework is on page 419, 4 through 8 all, 11 through 16 all, 22 through 29 all, 37 through 43 all, and 49 through 53 all. So a couple of things I want to just go over. In order to multiply or divide, you have to have the same index to multiply. That's the little bitty number. You also need to remember that the square root of x times the square root of x is x. So we use multiplication in two directions, actually. So here I have the nth root of ab is equal to the nth root of a times the nth root of b. So I can actually take this and break it up into these two. Or I can do it the other way where I'm multiplying the two together as long as the indexes are the same. In which case I get the nth root of a times b. So I have two examples up here. We rewrote this. This is square root of 25 times the square root of 3. We can simplify the square root of 25. We know it's 5. We don't know the square root of 3. So that's in one direction. In the other direction, we would multiply these two numbers together. Nobody's going to write that out. You're just going to give me the answer to the square root of 6. So the only thing we need to make sure about on multiplication is that the indexes are the same. So my next example, we're asked to multiply these together. So if I multiplied these together, I would probably not write 3 times 6 is 18. I would probably write 3 times 3 times 2 times a squared b, because I see where that's 3 squared times a squared times b, which I can simplify. 3 squared, which is 9, the square root of 9 is 3. I don't know the square root of 2. The index divided into the exponent goes once, with none left over. And I don't know the square root of b. Well, in simplest form, this is 3a times the square root of 2b. So 3a times the square root of 2b. You can multiply 3 times 6 and get 18 if you want to, but you're going to have to turn around and find the greatest common or the largest perfect square in the number. So that's why I didn't multiply the numbers together. So what's wrong with the first one? The indexes. So now we can't multiply these as they are, but later on when we get to rational exponents, which we're going to do on Monday, I'll show you how to do this. But in this case, think about this. This is 3 times the square root of 2 times 4 times the square root of 3. Multiplication is commutative because I could actually change the order of this and get 3 times 4 times the square root of 2 times the square root of 3, right? Nobody's going to write all that. But you can see where you're multiplying 3 times 4. You get 12. And then the square root of 6. Everybody good? On a problem like number 5, you probably should simplify this to begin with. It will make it a lot easier. Now this is 2 square roots of 3 times 4 square roots of 6. So 2 times 4 is 8. But once again, I would probably factor this. So 8 times 3 times the square root of 2, or 24 square roots of 2 would be the answer. You'll just have smaller numbers to work with, and it just makes it easier. You can multiply 12 times 6 if you wanted to. But it just makes it so much easier. Okay, so that brings me to a problem that looks like this. You're going to multiply these together. These are actually conjugates. We multiply to get a squared minus b squared, or the difference of 2 squares. You can FOIL it if you want to. We know that 2 times 2 is 4, minus 2 square roots of 3, plus 2 square roots of 3, minus the square root of 9. So we get 4 minus 3, or 1. But you really should understand that 2 conjugates always give you the difference of 2 squares. So you could have actually taken those numbers and squared the first term and squared the second term and gotten 4 minus 3, or 1. But you can FOIL them if you want. So my next examples, you will have to FOIL these. We're multiplying 3 times 2 to get 6, and then 3 times the square root of 3, and then we're multiplying these two together to get plus 2 square roots of 5, and these two together to get minus the square root of 15. Now, if there was anything I could combine, I would, but there is not, so that's the answer to the problem. Write it down twice, guys. If you don't write it down twice, half of y'all give me the wrong answer. You multiply these together, you're going to get 16 minus 4 square roots of 3 minus 4 square roots of 3 plus 3. Because the square root of 3 times the square root of 3 is 3, just like the square root of x times the square root of x is equal to x. So the square root of 3 times the square root of 3 is equal to 3. So we get 19 minus 8 square roots of 3. Everybody good? Not yet. So that brings me to my next example, number 9. All right, you're supposed to multiply these together, y'all. Well, 3 times negative 4 is negative 12. Then I have the square root of 15 times the square root of 15 times the square root of 3. Because 3 times 15 is 45. Everybody okay with that? And that's negative 12 times 15 times the square root of 3. So what is that, 180? Everybody good? All right, I'll give y'all a minute and get y'all to do this one. So did y'all get minus 22 minus 8 square roots of 5?
You said that like the square root of x times square root of x would be x. So my was at 25.
Well, I just wrote the square root of 25. It is 5. Alright, so on to division. Okay, what are conjugates? A plus B, A minus B are conjugates. A squared minus B squared is what you get when you multiply two conjugates together. Okay, the reason I've said that is because for division, we got to know what conjugates are. So once again, for division, as long as the indexes are the same, we can divide. So I have up here, and like I said, we work this both ways. Maybe I should have left that up there. So we'll start with,
Kristen, can you scroll up a little bit to that for all real numbers? Like right above that.
so depending on what we're doing, sometimes if you have like the square root of 3/4, it's better to write it as the square root of 3 divided by the square root of 4. The reason for that would be why? So the square root of 4 is 2. We get the square root of 3 over 2. Now to be in simplest form, we can't have any radical signs in the denominator. You don't want any radical signs in the denominator. On the next example, the nth root of A divided by the nth root of B can be written as the nth root of A divided by B. In this case, it would probably make more sense to write it like that and simplify it, because what's 6 into 24?
4.
4. And we know the square root of 4 is 2. Ready?
Oh, not you. Hold on.
Okay, so we've got these problems. And we see on the first example that 3 doesn't divide evenly into 16, so we can't simplify it. At least we can't simplify the fraction that's up there. We could rewrite this as 16 divided by the square root of 3. We know that the square root of 16 is 4. But I said a few minutes ago that we couldn't have any radical signs in the denominator, if not in simplest form. So we're going to do what we call rationalizing the denominator. We're going to get rid of the radical sign in the denominator. To do that, we're going to multiply the square root of 3 over the square root of 3. Well, the square root of 3 over the square root of 3 is 1. It's not going to change the value of it. It's just like when you're working with fractions. So we get 4 square roots of 3 over 3. So in simplest form, that radical, the square root of 16 over the square root of 3, is 4 square roots of 3 over 3. Okay. All right. So the next one, even if I rewrote this as 15 divided by 2, we couldn't simplify it, could we? So what do we want to multiply by? We want to multiply by the square root of 2 over the square root of 2 to get rid of the square root in the denominator. We can have a square root in the numerator, but we can't have a square root in the denominator. There are no perfect squares that go into 30, so we'd have to leave it just how it is, the square root of 30 over 2. Everybody good to go so far?
You put the square root of 2 over the square root when you multiply. So you like. Okay, that number you figure it out.
Abby?
Whenever you multiply numbers with an index like greater than 1, like maybe it's 3, would you have to, like if I was just doing...
Hold on, I'm going there.
Okay, sorry.
Just let me get through these. So here we multiply by the square root of 5 over the square root of 5 and get 2 square roots of 15 over 5. On problem example number 4, you guys need to simplify this first before you do anything. Okay? So what's the square root of x to the 4th?
X to the second.
X to the 2nd. And this would be y squared square root of y, right? Everybody agree with that? Okay, all you want to do is get rid of the radical sign. So you want to multiply by the square root of y over the square root of y. And you get x squared square roots of y over, well this is y squared times y. So how many y's have we got? 3. Okay. Okay. So in other words, if you've got a number and a radical sign in the denominator, you just want to get rid of the radical sign. Everybody understand that? So you just want to multiply by the square root of 2 of the square root of 2. And that gives you 4 square roots of 2 over 3 times 2 over 6. You could actually simplify that. 2 goes into 4 twice and into 6 3 times. I'm getting to your question, Abby, in a little bit. Just give me a minute. Okay. Everybody good?
This one.
So Abby, here I think is your question. You really need to take this example down, guys. I really think that this problem is really easier to work in a different way, and I'll do it in a minute. But you are trying to get x in the denominator for your answer, right? So my question to you is, how many x's do you need underneath this radical sign? How many? 3. Well, that would be, you need 3 under this radical sign, right? To get this. So how many am I going to put under this radical sign? 2. Because this plus this got to equal that, and these have to equal the same thing for me to get x. So this is 3 cube roots of x squared. That's 3 cube roots of x squared divided by x. Now personally, I think that's the hard way to work the problem. I'm going back to a concept we had a few minutes the other day where I said that x, the square root of x was equal to x to the 1/2 power. And the cube root of x was equal to what? X to the 1/3 power. So what I would do is I would probably rewrite this problem as x to the 1/3 power. Okay, so we want to multiply by something so that when we get x to the first power in the denominator. So what's the exponent got to be? What are we going to add to 1/3 to get 1? 2/3. Right? Because 2/3 plus 1/3 is equal to 1. Everybody agree with that? So this is 3x to the 2/3. Which when we get to rational exponents, we can rewrite this as the cube root of x squared over x. We'll do more of those later on. Okay? Was that the question you had, Abby?
Yes.
Sort of.
Oh, no, it wasn't. It's, if you just have, like, the index was 3, and then you have the square root of 2, and then you're multiplying that by
Hold on. Give me the problem if you're working for homework.
This isn't for homework. I just
Okay.
saw it on the board. It was the index is 3, and then the square root of 2, and then times the index is 3 and then the square root is 15. I'm just asking, would you have to put, if you got the square root of 30, would you have to put that 3 at the top?
Well, the index is going to stay the same.
Okay, that's what I was asking. Thank you.
Okay. So I have a number of more divisions to go. So I have these two examples. So on this particular problem, I've got to get rid of all of this. And the only way to get rid of the radical sign of the denominator when it's a binomial like this is to multiply by the conjugate. So what is the conjugate of 3 plus the square root of 5? 3 minus the square root of 5. So in the denominator, I'm going to get 9 minus 5. Numerator 2 times 3 is 6, minus 2 square roots of 5. So you multiplied this times 3, and then this times the square root. And I FOIL the denominator. So I get 6 minus 2 square roots of 5 over 4. That's really not in simplest form because I can divide 2 into 4 and get 2, into 6 get 3, and into 2 and get 1. What do I need to do first on this problem?
Get rid of the 2 minus.
Well, shouldn't I simplify the square root of 12 first? Well, this is 2 minus 2 square roots of 3. So then I want to multiply by what? 2 plus 2 square roots of 3. 2 plus 2 square roots of 3. So 2 times 2 is 6, plus 6 square roots of 3. So if I multiply the conjugates together, I'm going to get the first term squared, which is 4, minus 2 square roots of 3 squared. That's 4 minus 4 times 3. So that's 6 plus 6 square roots of 3 over negative 8. Now, I don't mind you having a negative number in the denominator. I think your textbook always gives you a positive number there. But we would need to divide 2, so we'll divide a negative 2 in that and get 4. Negative 3 minus 3 square roots of 3.
I'm not ready. Give me a few more seconds.
There's a homework exercise. That I want to do. It's not on here, but we'll find it. What page is the homework on, y'all? 319. It's problem number 51. That's not right. We'll start with this one. What's the conjugate of the denominator?
X plus, square root of X plus 1.
When we square the square root of x squared, we get x minus 1. Because x, square root of x times square root of x is x, and then we square 1, we get minus 1. If we multiply these on the numerator, we get x square roots of x plus the square root of x plus 1. That is the answer to that. But the reason I wanted to do that problem is because I also want to look at problem number 52. These are homework exercises. What's the difference in the problem that I just worked 51 and problem 52?
The radical signs of the negative 42.
Say that again?
The radical signs of the negative 42.
The radical signs over the whole thing. Yes. So it just really worked like this. What do we do to solve that? We just multiply by the square root of 2 over the square root of 2 and got our answer. Well, in this particular problem, that radical sign is over the whole thing. It doesn't look like this one. Okay? So we're going to just multiply by the square root of x squared minus 4 over the square root of x squared minus 4. And when we do, we get x minus 2 times the square root of x squared minus 4 over x squared minus 4. We're not really finished.
Can you simplify X squared?
Over 2 of the whole and x.
Now, I didn't multiply these in the numerator together because what can I do to x squared minus 4? What does it factor to? X minus 2 times x plus 2. So could we cancel x minus 2's? Yes. And we get x squared minus 4 over x plus 2. But that problem is different than one like this one, which I can't seem to make it go down anymore. So take this and move it somewhere else. They're not the same because the radical sign is not over the whole thing. Everybody understand that? All right, so that's really all we have.
Kimball.
I got it, sorry.
Very nice.
I have.
That's a fat lie.
I got that.
Does the biggest lie
I got
is
it.